Somewhere out in the dark between the stars, a chunk of ice has been drifting for 12 billion years. That's longer than our sun has existed. Longer than the Earth. Longer than almost anything you have ever been told is old. And here's the part that should stop you cold. The star it was born around is probably gone. Burned out. Dead. For billions of years. This is an object that outlived its own sun. And in the winter of 2025, it drifted close enough for us to actually read what it's made of. What our best telescope found, leaking off its surface, made one NASA scientist admit out loud that it didn't make sense. Stay with me. Because by the end of this, you'll understand exactly why this frozen visitor might be the oldest thing humanity has ever studied up close, and why part of it still has scientists stumped. Think about what this actually is for a second. Everything you know about other star systems, every fact about how planets form around other suns, comes from light. Faint light gathered from unimaginably far away, and interpreted by people who will never touch the thing they're studying. We have never held a piece of another solar system. We've never measured its ingredients directly. Except now, 3 times in all of human history, a piece of another star system has come to us. And this third one is the biggest, the brightest, and by far the strangest. By the end of this video, you'll understand exactly why researchers are calling this the most valuable interstellar object we have ever caught, what our telescopes pulled out of it, the one signal nobody can fully explain, and why some scientists now believe it is older than the galaxy's own middle age. Before we go further, if you want the real verified space stories, the ones backed by actual data and not the wild guesses flooding your feed, hit subscribe right now, because this is where the truth lands first, and we track these discoveries as the science actually comes in. Now, to understand what just passed us, we have to go back. Start simple. Our solar system is a family, 1 star, the sun, 8 planets, moons, asteroids, comets, countless smaller pieces, and every single one of them is held on a leash. That leash is gravity. It pulls everything back, again and again, locking each object into a loop around the sun that repeats forever. If it orbits the sun, it belongs here. But every so often, something shows up that was never on the leash at all. Something that didn't form here. Something that came from out there, from another star, from deep in the galaxy, and is only passing through once, on its way to somewhere we'll never follow. These are called interstellar objects, and in all of recorded human history, we have confirmed exactly 3 of them. The first appeared in 2017. It was small, oddly stretched out, tumbling through space in a way nobody could quite explain. It showed almost no visible activity, no gas, no dust, no comet tail. It stayed quiet, and by the time our telescopes truly understood what they were looking at, it was already too far, too faint, gone. It left more questions than answers. Some of its behavior is still argued about today. The second arrived in 2019. This one behaved. It had a glowing cloud around it and a visible tail. It looked and acted like the comets we already knew from our own backyard. Scientists got a much richer look at it. But even then, by the time the instruments were fully trained on it, it too was already leaving. Both times we were late. Both times we were scrambling. And both times scientists were left hungry for a third chance. A bigger one. A brighter one. One that showed up with enough warning that the world's best instruments, including telescopes that didn't even exist back in 2017, could line up and get a proper, unhurried look. That third chance came. And it did not disappoint. July 1st, 2025. A survey station in Rio Hurtado, Chile, catches a faint, fast-moving point of light crawling across the night sky. This station is part of a network called ATLAS, the Asteroid Terrestrial Impact Last Alert System. Its whole job is to scan the sky every clear night, hunting for objects that might one day threaten Earth. Most of what it finds is ordinary. Harmless rocks, drifting where they should. But this one moved wrong. Astronomers checked its path, ran the numbers, and within days, they had their answer. An answer that changes everything about how you have to treat an object. It was moving too fast for the sun to hold it. It wasn't going to loop back. It wasn't caught. It was going to fall past the sun, whip around, and shoot straight back out into deep space, never to return. This was the third confirmed interstellar object ever recorded by humanity. They named it 3I Atlas. The 3I marks it as the third interstellar visitor. The Atlas honors the survey that caught it, and right away it stood out. But that's not even the strangest part. Here's a simple idea that unlocks this whole story. The shape of an object's path tells you where it belongs. A gentle curve that loops back means it's family, bound to the sun. A path that comes screaming in, bends only slightly, and rockets straight back out means it's a stranger, just passing through. Scientists measure this with a number, and 3I Atlas had the most extreme number of any object like this ever recorded, far more extreme than the 2 visitors before it. Its path barely bent. It was the most dynamically extreme trajectory ever measured in our solar system. And the speed? Before the sun's gravity had even really grabbed it, this thing was already moving at around 58 kilometers every second. That's not a typo. Per second. And as it fell toward the sun, it only got faster, screaming past 68 kilometers per second at its closest approach. It's the fastest comet ever recorded. Now, why does raw speed matter so much? Because speed, in this case, is a clock. And when scientists read that clock, they got a number that genuinely stopped them. Here's where it stops making sense. The speed of an interstellar object isn't random. It carries a memory. As an object drifts through the galaxy for billions of years, it gets nudged again and again by the gravity of everything it passes. The stars, the gas clouds, the galaxy itself. Slowly, over enormous spans of time, the constant nudging speeds an object up. So in a rough sense, the faster one of these wanderers is moving relative to the stars around it, the longer it has likely been drifting. And 3I Atlas was moving fast, very fast. A research team at Oxford, led by a graduate student named Matthew Hopkins with his advisor, ran the numbers through a statistical model they'd spent years building, a model designed to do something never really possible before. Take the path of an interstellar object and estimate where in the galaxy it came from and how old it likely is. Their result was startling. 3I Atlas, they estimated, had roughly a 2/3 chance of being older than our entire solar system. Their best single estimate landed near 7 billion years old. For comparison, our sun and everything around it is about 4.5 billion years old. That alone would make it the oldest comet humanity had ever seen, but it points to something even bigger. The path traced back toward a region of the galaxy called the thick disk, an ancient population of stars that sits above and below the flat plane where our sun lives. These aren't middle-aged stars like ours. Many of them formed in the galaxy's first few billion years, some of the oldest stars anything has ever observed. If 3I Atlas came from there, it formed alongside one of those ancient stars. And that raises a haunting possibility, because stars don't live forever. Take that in for a moment. If this comet is that old, then the star it was born around, the sun it once orbited, the light it once knew, may have died a very long time ago. Ancient stars of that kind swell into red giants, cast off their outer layers, and leave behind a burnt-out core. Its home star could be long gone, its home system scattered, which means this object may be, quite literally, a fragment of a solar system that no longer exists, a frozen orphan, flung out of a system that has since gone dark, drifting alone in the cold and the silence for longer than the sun has burned, carrying its original chemistry locked inside, untouched, until the exact moment it crossed paths with us. If that alone doesn't stop you, I don't know what will. And here's the thing. That 7 billion year estimate was just the beginning, because the next number to come out of this comet was even more extreme. I'll get to it. But first, you need to understand how we read the secrets of a thing this small, this fast, this far away. Because that part is where the real surprises started. Here's what made 3I Atlas different from that silent first visitor back in 2017. It came alive. As it fell toward the sun, it heated up, and the frozen material on and beneath its surface began turning straight from solid ice into gas, streaming off the object, forming a glowing cloud around it called a coma, along with a faint tail. This is a bigger deal than it sounds. A silent, inactive rock keeps its secrets. It gives you nothing. But an active comet, venting gas into space, that comet is practically handing you its ingredients. Because once that material is out in the open, our instruments can catch the light passing through it and read the chemistry directly. And 3I Atlas was venting. It was also, by interstellar object standards, big. Early estimates of its solid core were debated. Some initial guesses ran as high as several kilometers across, but refined measurements pointed to a nucleus on the order of a couple of kilometers wide, larger than either of the two visitors before it. And a bigger core means more surface to heat, more gas released, a brighter coma, and a stronger, cleaner chemical signal for our telescopes to lock onto. So this time we weren't late. This time we had months of warning. And this time we had a telescope that didn't exist when the first visitor slipped past us. Which brings us to what actually read this thing. Quick pause. If this is pulling you in, drop a subscription now, because we're about to get to what the James Webb Space Telescope actually found. And it's stranger than most people expect. The James Webb Space Telescope, Webb, or JWST, is the most powerful space telescope humanity has ever built. It doesn't see the way your eyes do. It's tuned to infrared light, longer wavelengths, invisible to us, that carry heat signatures and, crucially, chemical fingerprints. It can read what a distant, faint object is actually made of. There was just one problem. Webb wasn't really built to chase small, fast-moving objects streaking across the sky. Tracking something moving as fast as 3i Atlas pushed the telescope's pointing systems in ways they weren't designed for. But the teams managed it. Before the comet reached the sun, Webb and other instruments caught early readings, fingerprints of water, carbon dioxide, and carbon monoxide venting off the object. And right away, one thing looked off. The comet was releasing an unusually high amount of carbon dioxide compared to water. That ratio stood out. Comets born in our own solar system tend to follow familiar patterns in how much water versus carbon dioxide they give off as they heat up. This visitor broke the pattern, a first hint that whatever environment built it was chemically nothing like our own. Then the comet swung around the sun, and after it did, heading back out into the dark, Webb turned to it again in mid-December of 2025, using a different instrument tuned to mid-infrared light. That's when it found something no one had ever detected on an interstellar object before. 2 dates, December 15th and 16th, then December 27th, 2025. As the comet drifted back out, Webb's mid-infrared instrument read its chemistry cleaner than any interstellar object has ever been read, and buried in that data was the clear signature of methane gas. The first time, ever, that methane has been directly detected coming off an interstellar object. Alongside it, water vapor, carbon dioxide, and organic molecules, the kind of carbon-based chemistry that catches every scientist's attention. But then came the part that made a NASA scientist stop. Webb also picked up a very specific atomic signature, the fingerprint of nickel, a metal, escaping as vapor from the comet's coma. And the researcher leading that Webb analysis openly admitted the nickel didn't fit. He said, in effect, that it doesn't make sense, and that it's a question for another day. Not a claim, not hype. A working scientist, looking at real data from the most advanced telescope ever built, admitting a piece of the picture doesn't line up with what we understand. Sit with that. We caught a piece of another star system, read its ingredients directly, and it handed us a detail our current understanding can't fully explain. But this raises a terrifying and beautiful new question. Why is there so much methane on something this ancient at all? Here's why methane is such a puzzle. Methane is a small, simple, fragile molecule. And an object that spends billions of years drifting alone through interstellar space is bombarded constantly by raw cosmic radiation, with nothing to shield it. Over that much time, that radiation should strip away and destroy the methane near the surface. So, scientists didn't necessarily expect to find a strong methane signal on something this old. And yet, there it was, loud and clear. Where was it coming from? The leading interpretation is this. The comet's outer layers had indeed lost most of their original methane over billions of years, cooked and scoured by radiation. What Webb was reading wasn't the surface. It was methane escaping from deeper material, unprocessed, shielded, locked away since before our own sun existed, and only now boiling free as the comet's outer skin burned off in the sun's heat. In plain terms, Webb wasn't looking at the surface of an ancient traveler. It was looking straight into material that had been sealed away, untouched, since before our solar system was born. And there was one more clue hidden in that methane. A version of it carrying an unusual amount of a heavy form of hydrogen, a chemical marker that scientists use as a fingerprint of the conditions where a molecule first formed. That marker, too, hinted at an origin utterly unlike home. But the single biggest number was still coming, because a separate team was about to push the comet's age far past 7 billion years. While Webb and others were reading the chemistry, a team led by a scientist at NASA's Goddard Space Flight Center went hunting for the comet's true age using a completely different method, and published it in the journal Nature. Instead of using speed, they used carbon. Carbon comes in slightly different forms, heavier and lighter versions of the same atom. The exact balance between them acts like a birth certificate. It records the kind of environment a molecule was cooked in. And in 3i Atlas, the balance was unusual, pointing toward carbon forged in a very specific, very ancient process inside old stars, sometimes called hot bottom burning. When they worked it through, the number that came out was staggering, roughly 12 billion years old. Not older than the sun by a little, nearly 3 times older, born within a few billion years of the birth of the entire galaxy. If that estimate holds, this isn't just the oldest comet we've ever seen. It's a frozen relic from the early universe, a specimen from an era when the Milky Way was young and our sun was still 10 billion years away from ever igniting. An object so old that, as one report put it, its home star system may simply not exist anymore. We didn't just catch a piece of another solar system. We may have caught a piece of the ancient galaxy itself, delivered to our doorstep by 12 billion years of silent drift. And of course, an object this strange, this old, this fast, the internet had other ideas. If you're still here, you clearly want the real science, not the noise. So hit subscribe, because there's one more part of this story a lot of people online got completely wrong, and I want to set the record straight with you. Because 3i Atlas was so extreme, so fast, so old, so unusual, some corners of the internet ran wild. Maybe, they said, it isn't natural at all. Maybe it's a probe, a ship, a message. Now, that instinct is human. When something strange arrives from outside, it's natural to wonder what else it could be. And here's what I respect about the scientists. They didn't laugh it off. They checked. They pointed some of the most sensitive radio instruments on Earth directly at 3i Atlas, listening for what's called a technosignature, any artificial radio signal that would suggest the object was built, not born. The SETI Institute used the Allen Telescope Array. A breakthrough listen team used the giant Green Bank telescope less than a day before the comet's closest approach to Earth, sweeping a wide range of frequencies. Another team used the enormous FAST telescope across multiple dates from October through January. The result? Silence. No credible artificial signal. Nothing. The searches were sensitive enough to rule out even a faint transmitter, weaker than a household appliance, and they found nothing at all. Every piece of data, Webb's chemistry, the imaging, the radio searches, points to exactly what an ancient natural comet should look like. Its behavior matches known comet physics. Its chemistry, unusual as it is, still fits an icy body born around a different star. Its coma, its gas, its dust, all natural. And I don't tell you this to kill the wonder. I tell you this because the real story is already more astonishing than the rumor. A confirmed visitor from another star system, possibly 12 billion years old, carrying chemistry frozen since before the sun existed. Read directly by our most advanced telescopes, with one signal even the experts can't fully explain. It doesn't need aliens. The truth is stranger, and it's real. So what does any of this actually mean? For you, for us, for a future none of us will fully see? Start with the obvious. Every interstellar object we catch is a physical sample of somewhere else, not a guess from distant starlight, an actual measurement of the raw ingredients that built planets and comets around another sun. We've had 3 chances like this in all of recorded history, and 3i Atlas gave us by far the richest data of the 3. But there's a bigger picture forming. For a long time, scientists genuinely didn't know whether these visitors were freak, once-in-a-lifetime events, or whether space is quietly full of them, drifting past us unseen, simply because we never had the tools to catch them. 3 confirmed objects in less than a decade, with our detection technology improving every single year, hints strongly at the second answer. And this is where I want to be careful and honest with you, because this next part is informed speculation, not confirmed fact. Many scientists expect that as newer, more powerful survey telescopes come online, including a brand new observatory built to scan the entire visible sky every few nights, the rate at which we catch these objects could climb sharply. Some estimates suggest we may go from finding one every few years to finding many. If that's right, 3i Atlas isn't a rare miracle. It's the third of what could become a steady stream of ancient visitors, and the first one big enough, bright enough, and early enough for us to truly read. Which should change how you look up the night sky tonight, because somewhere out there, right now, more pieces of other solar systems are almost certainly drifting through our own, ancient, frozen, unnoticed, waiting for the next telescope lucky enough to catch them before they slip back into the dark. There's one more thing I need you to sit with, because it might be the most humbling part of all. Think about the timeline this object has lived. It formed billions of years ago, around a star that may not even exist anymore in a region of the galaxy we have never studied up close. At some point, something flung it out, a gravitational shove, a close pass with another star, and it began to drift, alone, no star to orbit, no light to warm it, just cold and silence and time. For possibly 12 billion years it drifted like that, carrying its original chemistry, frozen, sealed, untouched. And then, purely by chance, its endless journey brought it close enough to our sun that our gravity could bend its path, and our telescopes could finally catch it. Now look at us. Telescopes have existed for about 400 years. Space telescopes that can read the exact chemical fingerprint of a comet have existed for a few decades. Out of 12 billion years of silent drifting, this object happened to pass our sun during the one impossibly narrow window of history when we had both the knowledge to recognize it as a stranger and the technology to read its secrets in real time. A few hundred years earlier, it would have been nothing but a faint, unexplained smudge in the sky. We happened to be alive with the right instruments pointed at the right patch of darkness during the one brief moment this ancient traveler passed near enough to notice. That is a stroke of cosmic timing so improbable, it's almost hard to hold in your head. And it took an extraordinary quiet act of global teamwork to make the most of it. A ground-based survey caught it first. Observatories across multiple continents confirmed its path within days. Space telescopes run by different nations took turns studying it from orbit. Radio arrays listened from an entirely different part of the spectrum. Teams around the world shared data and coordinated schedules, all racing toward one shared goal before this visitor faded from view for good. We had one window, and humanity, working together, didn't waste it. So let's close the loop I opened at the very start. I told you a chunk of ice had been drifting for 12 billion years. That's the nature team's estimate, from the carbon locked inside it. I told you the star it was born around is probably gone. That follows from its age and its origin in the galaxy's ancient thick disk. An inference, but a grounded one. This may truly be a fragment of a solar system that no longer exists. And I told you Webb found something that didn't make sense. The nickel. That's real. A working NASA scientist admitted the signal doesn't fit our current understanding. It remains, in his words, a question for another day. That's the honest shape of it. A visitor older than our sun, maybe older than most of what we've ever observed, that came alive as it passed us, handed our telescopes the first methane ever read off an interstellar object, and left behind one small mystery still waiting for an answer. It's already gone now. Its path carries it back out of the solar system into the dark, on a road that will never bring it near our sun again. Whatever it does over the next several billion years, drift or wander or fall toward some far-off star, is no longer ours to watch. We got one look, and what a look it was. If this shook you the way it shook me, hit subscribe and turn on the bell, because the next discovery is already coming. New survey telescopes are switching on right now, and the scientists expect the next interstellar visitor to arrive with even more warning, and even more of our instruments waiting for it. Drop a comment and tell me the age, the dead star, or the one signal nobody can explain, which part got you the most. And if you want to understand the object that started all of this, the very first interstellar visitor, the strange, silent one from 2017 that scientists still argue about to this day, watch this next. Because that story is where the mystery really began. I'll see you there.